opening speaker this afternoon is Randy Bush, who's going to be presenting RPKI ecosystem measurement. Randy is a research fellow at the Internet Initiative Japan and a fellow at ArcSync, and has traveled today from Portland, Oregon to talk to us. Randy is one of those people who's presented more times than we actually have records for. But we think the first time was at Nanog 6 in San Diego in 1996. And there's been definitely a lot more than that. So we'd like to welcome Randy back for his latest appearance. Welcome, Randy.
Hi. I didn't come from Portland. I've been here all week. Okay. The heavy lifters, the real heavy lifter was Romain. I just occasionally made useless comments on this research. This is actually a research presentation. I'm going to talk about the experimental setup, then the measurement of propagation of the RPKI data, then on the effect of BGP, and sorry, there'll be a whole bunch of CDFs, the problems and the anomalies, what we need to do with RPKI distribution downstream to improve the problems we'll see, and then a asynchronous warning, not just about RPKI, but it's one of my, I always have to rant against complexity. Romain had to present this at PAM, the academic conference where this paper was, so he first had to describe the RPKI. The RPKI was done outside the IETF, brought in, and the IETF is great at complicating things, and it's moving right ahead with the complexities right now. There's a good working group, CyDrops, if you wish to see spaghetti being made. So we think about three planes in our network. The management plane, which we get data coming out, telemetry, SNMP, etc. We push configuration down. The management plane then pushes it down through mechanisms you've heard about earlier today, or this week, which is all sorts of arcane things, Ansible, etc. The control plane drives it, and that's the routing protocols. And then that drives the data plane, which is the packet forwarding, which is what the exercise is about. Now we're going to chase Route Origin validation from up, where the certificates and everything are generated, down through the management plane, to BGP in the control plane, to the actual payload and IP, MPLS, etc. Now, the money is way down at the bottom. They pay us to move packets. But the control is way up at the top, where we use RARs to change and maintain the data. So what happens if something goes wrong if I create a bad ROA? How long and how quickly can I fix it? And that's the bottom line of this, and right now it's too long. The experimental setup is we want to measure, and I'm sorry, pointers don't work with dual screens. So we want to measure the data on the left side as it goes down from that term query is when we push the button on the RIR's web interface and say create a ROA. Or if we're lucky, the RIR has an API, and so we can do it without screen scraping. Then the RIR occasionally signs the ROA. Then the RIR pushes it to their publication point. Then the ISP's validator fetches it from the publication point. Then Their router gets the data and uses it to validate BGP announcements and withdrawals. And that updates BGP, and then it finally goes over into the control plane on the right. And we look at the BGP updates through the route collectors. And then just for fun, we test the data plane using RIPE Atlas probes to send packets flying towards the destination and see if they get there. The experiments were we got prefixes from each of the RIRs we got in V4 and V6 space. We announced that this part of the experiment we announced from a single AS, and that AS had both validating, route origin validation upstreams and some prayers which were not. We got another set of RIPE-only prefixes, and we did a totally different set of experiment from purely non-ROV upstreams over in Asia Pacific. And these measurements were taken over 11 months. We did with these prefixes, we did what we can call ROA beacons, which is we used either the API, if the RIR provided one, or we had to do GUI screen scraping at each RIR to create and delete ROAs. The prefixes for which we were generating ROAs are divided into two categories. The control group, which should always be good. So they're just a constant, start at the beginning of the 11 months, with a ROA that validated it, and we're always announcing it. The test prefixes, 24 in V4 and 48 in V6, always have a constant invalidating ROA, and then we alternatively generate a validating ROA once a day for half the day, jittered and slightly randomized. And you have to remember that if the router gets a valid ROA, no matter how many ROAs invalidating are there, the valid ROA says you're cool. So that's a beacon that says, lets the invalid rule or overrides it with a valid. So we see it going up and down all day. We want to measure propagation of the RPKI data, those announcements and deletion of the validating ROA. Click. Okay, so this is the delay of ROA creation. And you can see there's something funny happening at APNIC, which is they batch sign every 20 minutes, which is why you see a mean of 10 minutes. Boo hiss. Okay, then we see, and by the way, the parentheses are V6. Then we see something's funny in Aaron and Lacknick. What turns out to be funny, and it took us a while to notice this, we started the experiment, we let it run for a couple months, and then we started analyzing data, and we went, whoopsie, what's happening here? And we can see it in more detail in future slides, but they had their hardware signing being done with HSMs, and HSMs, because they're for real, run in GMT. They were running their RPKI servers in their local time zones. This means that the not before value appeared hours before the publication. We reported this, they did workarounds, but as you'll see in the CDFs, it took a long while to take effect, so it skews things seriously. And you can see that it causes significant delay in the next thing, which is when it gets to relying parties. Okay, so you see 3 of the 5 RIRs are injecting artificial delay in what is a not too bad process. Okay, so the creation times vary significantly. They can be a few minutes to over an hour. There is a NIR. We don't have that in North America, but in Asia and Latin America, they have national registries. There's an NIR, at least one in Asia, that only publishes once a day. You make a mistake that kills your announcement, and you wait at least a day. This is not cool, okay? Originally, APNIC only committed to once a day, but rationality prevailed. They're down to 20 minutes. We measured at a relying party. We had one instance of relying party software. You might want to look at Philip's measurements that's comparing the effect of different routing property software packages, and they're not pretty. We did not run the final step to test routers because, first of all, there are too many routers times the cross product of too many relying party software packages. And secondly, the protocol between the relying party cache and the router is supposed to be on notification boom, 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 boom basis. So it should be ridiculously quick. And when we see the effect on BGP as compared to the relying party, it looks pretty good. And unfortunately, some relying parties had head of line blocking. In other words, they go along and they want to fetch, and they hit the CN-NIC1, which is behind the firewall, which is broken for the minute, and they stay there, and they stick, and they don't continue. I keep sending them the man page for fork and exec, and they'll eventually figure it out. Okay? Then we go to the collectors, the classic ripe risk collectors. You heard the route view presentation earlier. We happen to use ripe's clone of them. We recorded both the control and the test prefixes at the collectors. If the control is missing, discard that whole measurement, because the control is there to say things are working. Okay, you're now measuring the effect on the BGP control plane. We used only 2 of the collectors because they're big, and research has shown adding a whole bunch of collectors doesn't really help. And we've been discussing the bias of the collectors for years. The collectors are essentially what I term in the clue core of the internet. So doesn't represent the edges, doesn't represent funny stuff, but it's what we got. ROA revocation delay. In other words, I go to the RIR interface and I say, delete that ROA. We see APNIC's 20 minutes, but we say a big skew. And this was because an RP would hang. The relying party software would hang occasionally on a ROA and keep it sticky out there, just like we have BGP zombies. Well, we've got ROA zombies now. Bonus, no extra charge. Okay, so what's the effect on BGP? I threatened you with Grotti CDFs. Here's the first one. Here's the 4 and 6 for the 5 RIRs. You can see the LACNIC and Aaron TimeZone Bugs scream at you. Notice you're looking at about 10 minutes. To get 50%, you're looking at about 20 minutes to get 50% of your ROAs out there. Okay, the time zone bugs I've talked to you about. Withdraw is slower than announce. The reason withdraw is slower than the announce is ISPs tend to have 2 or more relying party software caches. And since the router only needs 1 validating ROA, if either of the caches has a validating ROA, then it stays valid. So if the withdrawal gets to one of the caches and not the other, your ROA is still, the BGP announcement is still valid until the withdrawal gets to the second one. So That's why withdrawals are slower than announces. You can see this for all the RIRs, but here we're looking at two particular ISPs, NTT and Sprint. Sprint pulls less frequently than NTT. The ROAs poll the RIR. Okay. And they also were running not the greatest RP software. They switched partway through. Sprint starts earlier because they poll frequently. Okay. The routers poll the cache more frequently. And we confirmed it, and they adjusted some things. So the withdrawals are slower than the announce. We've got the stuck ROA bug. We've got the time zone bug. You change your ROA. How long does it take to delay? Look at these are across seven different ASs, right? And you'll recognize them if you're a router geek. And there you see the slower pollers way skewed to the right. And you'll see it never reaches always 100% for somebody. And that's the stuck ROA bug. So the withdraw, the delay is significantly more, right? Okay, and there's the stuck ROA bug again. Okay. So then we want to do the data plane. This is going to be boring because it actually works. Once you get it to BGP, you're cooking. Okay? We ran traceroute from Atlas probe to the test prefixes every 15 minutes, from Atlas probes all the heck over the place. How many people here know what Atlas probes are? Good. So the results are very similar to BGP. You get what you expect. The one interesting thing is, how many people here know what path hunting is? Okay, so it's worth an explain. My router has two upstreams. One of them, so I've chosen my best path. I've chosen her as the best path. She withdraws. I'm holding the path for the other one, so I fall back to it. That's path hunting. If I'm at an IX, I might have 50 peers or 300 peers if you're at Seattle. Okay? So when there's a withdrawal from one of them that beats the others, you'll go hunt, 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 selecting a best path until you run out of them. And what's cute is you can actually see it here. The red verticals are the withdrawal. And you can see especially 3257, when it sticks around for a long time after the withdrawal from the others. So you still got it all reachable for, seconds afterwards. And that was the only interesting thing we learned on the data plane. We already knew of path hunting, of course, but it was cute to actually see it. Okay, so we have two big sources of delay. The RIR, publication delay, and the ISP pulling from the publication point and getting it to BGP. Some of the problems and anomalies, as I said, we had Aaron and Lacknick, who fixed their time zone anomalies. We have the relying party delay, which is significant. Even for APNIC, AFRINIC, and RIPE, who published well and quickly and didn't have the GSM problem, we still see significant delay. We're looking at BGP that propagates in seconds and a minute, two at worst. And we're talking about 15 minutes here. That's certainly we can do better than that. So BGP propagates in minutes. RPKI can take an hour. This has business impacts, and the two poster children for the business impact is the time to repair when I've broken my routing with a bad ROA. And if I'm suffering a DDoS and I go panic and my business people always refuse to pay for a DDoS mitigator, and now they're willing to pay for it real quick. Well, how quick before I can put a ROA for fat lease AS numbers, right? So the RIRs that had HSM skew, head of line blocking and slow RPs. And another thing we found is if you actually dissect the ROAs, they were actually legally, but shall we say interestingly different anatomically if you looked on the inside. And we're still working on that and discussing it. Realized the limitations of the study was cruddy relying party software. I'm not fond of any of the relying party software out there. As I said, we didn't measure BGP to router, RPKI to relying party cache to router, because that should be a second or three. Okay? We did not measure delegated CAs. There are big ISPs out there who get a subsidiary CA under the RIR. And there's too many of them, and we weren't going to be able to instrument them all. Okay? And God, did we hate having to screen scraping instead of the APIs. And as I said, when you saw the stuck announcement, that some of the APIs didn't even work. This was the actual paper in PAM, and it's available with even more gruesome detail and way too many more CDFs. So what can we do? Where do we go from here? Go faster. CAs, please publish more frequently. There's no excuse for delay. If the relying party is using the RRDP protocol, there is no reason not to poll at least every 10 minutes, because if modified since timestamp is there, caching makes the load on the server just negligible and ignorable. Have your RPs poll the publication points not so frequently if you're using rsync, and you can tell which you're doing by which URL you're doing. Maybe rsync goes all the way to the server. It's a really nice protocol, especially for debugging, but maybe just do it every 30 minutes, sorry, when we're trying to get rid of rsync. As protocol designers, unfortunately, BGP is the only large-scale protocol that's push. Okay, all the rest, like DNS, SNMP, et cetera, all pull protocols. So it's polling, so it depends upon that timing. Well, wow, if BGP is such a great push protocol, why don't we just transport RPKI over to BGP? Well, something called share fate. And we can immediately, probably half this audience in 30 seconds can think of instances where if the RPKI data could break the BGP, that you can't get fixing the RPKI data to fix it. Also, at every hop, BGP is guaranteed to reorder the announcements, which is just a mess. We did back in '98 try to do it with DNS. If I currently have as my upstream ISP, Katrinsky, and I want to switch to Doug Montgomery over there, what I want to do is create a ROA. I've got a ROA to Cat. I want to create a ROA to Doug, but DNS, I can't have two delegations at the same time to different ASs if I've got the AS coded in it. Okay, but we did publish it in a draft, but we ate it over 20 years ago. We fantasize about a flooding protocol for the management plane that is immune to routing attack. So far, it's fantasy. Okay, and now I promised you a plea for simplicity. Back in 2018, Bert published the DNS Camel, or the rise in DNS complexity, and what a mess it was. Well, 18 years earlier, I gave the same talk, except it was saddlebags on a horse, right? And it was the same thing, the complexity of the DNS. And for anybody who actually works in DNS, I think you know how bad it is. I'd quote one of the greatest computer scientists of my lifetime. The main challenge is not to get confused by the complexity you make. Don't make the complexity. Okay, there's another great story, which is debugging is twice as hard as coding. So don't code to your max ability, because then you won't be able to debug it, because it's twice as hard. Okay, and we have facilities for doing permissionless research. We've got a POP over here in Como, and all sorts of people have donated bandwidth, rack space, et cetera, for which we wish to thank them. And that's the story, and we have 3 minutes for questions, unfortunately. Sorry. Fergus, are you going to pretend to moderate this? You might.
Quick reminder, name and affiliation, please, for questions.
Steve Wallace, Internet 2. Thanks for the presentation. Thank Ramon for his ROV Python library, which is very useful. So it sounds like if you mess up and create a ROA that's causing a problem, the first thing you should do is create a ROA that will fix the problem and then worry about deleting or withdrawing the ROA that caused the problem.
Not this. I agree with you entirely. I never make mistakes, so it's not a problem. I'm sure you never make mistakes either.
Thanks.
Marco Sanz from The Geeks. Thank you very much, Randy. You know better than me, but I think that in the RFC, the default for the refresh period for the router to poll is 3,600. Are you suggesting that that default should be changed?
No, not for the router to go to the relying party software, because the second thing is, you'll notice the notify PDU, where the cache, well, this guy just checks every 3,600.
Yeah.
This relying party software gets a change from upstream. It sends a notify to the router that says, hey, wake up, poll me now.
Understood. Thank you.
Hi, Rich Compton Charter. What do you think about getting rid of the rsync protocol?
We're working on it.
Do you think this is something that we should do, and it's not like
Well,
it has a benefit to have redundancy there? You think we should just get rid of it?
It's really nice for debugging. It makes things very clear, et cetera. But is there a need for speed?
Yeah, you have the CDNs you can do with
Yeah.
RDP,
Well,
you can do
this-
with rsync.
Well, back when we designed this stuff 20 years ago, we were hoping that the CDNs would cache rsync for us,
Yeah,
and nobody stepped up.
yeah.
So, but rsync is slowing things down because it does load the server.
Yeah. Okay. Thank you.
Sure. Michael.
Michael Sinatra, ESNet. Sorry. You mentioned that you don't like any of the RP software. Do you have any recommendations for something that is least sucky?
No.
And
No, not because I think they all suck equally. It's because I have not tested well enough to say anything. Maybe you should talk to the tall gentleman over there.
one quick follow-up. Do you have any, those bugs that you talked about where
Head of line blocking.
yeah, do you have any, are those being addressed? Are those being fixed? Or is there anything we can do to try to get?
I'm getting pushback, and oh, it's difficult, et cetera, et cetera. The fact is, the United States government paid us to write the prototypes that don't have those problems years ago. The code is out there. Steal it. It's open source.
We have a question from a remote participant, although not actually remote. Kate Jerry asks, you mentioned removing rsync protocol in favor of RDP, but from what we understand, RDP does not allow for delta resyncs, while rsync does. So if an update fails with RDP, then the future attempts require a full synchronization.
Part of it is trying to get that protocol updated.
Okay. This seems to be a current ongoing issue with Afrinix repositories.
We had LACNIC last week. Not just Africa.
Fair enough. Thank you.
Every RIR has screwed up. The protocols were designed expecting that. One thing that's cheery about the RPKI stuff, it was designed by a conspiracy of operators, vendors, security, crypto, etc. So it doesn't have some of the scary underlying flaws that, for instance, BGPsec has that make it very difficult to operate. So you can knock out LACNIC for a day and nothing bad will happen. Thank you.
Any more questions for Randy?
I think you're out of time. I think you're out of time.
Well, yes, but we did start late.
Ah.
Thank you again, Randy.